So I think it's part of what we explained yesterday. So it is called Avogadro's number. Avogadro. Some people call it Avogadro's constant too. So 6.02 times 10 to the power 23 is Avogadro's constant. The next one, or Avogadro's number. The next one is a chemical formula which shows the actual number is called, so a chemical formula which shows the actual numbers and the types of atoms present in one molecule of a compound is called what? Normally, we have types of this. A chemical formula, we have two types. We have the simplest formula, which is empirical formula, and we have the actual formula, which is molecular formula. We have the simplest formula, which is empirical formula, and we have the actual formula, which is the molecular formula. So the empirical formula is the simplest form in which a compound can be represented formula-wise. So what we mean by this is that glucose is a compound. It's an organic compound. C6H12O6. That is the formula for glucose. So now this glucose now, if we want to cut it into ratio, we can absolutely write C6H12O6 as C1H2O1, right? C6H12O6, CH2O. That means C1H2O, H2O1. That's what we mean by that. So that is for empirical formula and molecular formula. So the answer to this one is molecular formula, because it is the one that will write the C6H12O6 now is the molecular formula of glucose, while CH2O1 or CH2O can just be an empirical formula for it. A chemical formula which represents the elemental composition of a formula unit of the compound in terms of the smallest whole number ratio of the atom present is called. So this one now, this is actually what I explained earlier. That is the empirical formula. They said which the smallest, in terms of smallest whole number, that means it has cut it into ratios. Smallest whole number, that's what that implies. Smallest whole number, that's what it means. So keep. The next question is this. I don't want to calculate anything. The number of atoms in atomic mass of every element is called what? The number of atoms in atomic mass of every element is called what? Is there anyone that will tell us the number of atoms? That's called what? It's showing in my screen. What's the answer? Oh, you guys should reply.
Mole.
The number of atoms in atomic mass of every element is called mole. So the unit of mole is MOL. You won't write, when you calculate something, I want to write the mole, it will be MOL. It won't be MOLE. That is the unit, MOL. Some people always put dot too after the MOL, but it's okay to leave it as MOL this way now. So the next one says calculate the formula mass of potassium carbonate. Formula mass means molar mass, the relative molecular mass. So what is the formula mass of potassium carbonate? You have to write the compound out first. What is potassium carbonate? That is K2CO3, potassium carbonate. What they mean is, the old name is potassium carbonate. It is actually now potassium trioxocarbonate form. So calculate the formula mass of potassium carbonate. They are even giving us the mass number of all the components. So K2CO3, you are going to calculate K, that means the mass number of K, add it to the mass number of C, add it to the mass number of O, in accordance with the number in that compound. So K2CO3, I think you guys are writing it down. I'm actually not holding any pen. I seriously don't feel like. So if you guys are with me, should just be jotting it down that way. And so now calculate the formula mass of potassium carbonate. That is K2Cr2O7. So we are going to write potassium is 39. So that means 39. We said K2. I said Cr2. Oh, I said rubbish. K2CO3. K2Cr07 is another compound. That's potassium heptazodichromate 6. This is K2CO3. Sorry for that. K2CO3 is the compound we are talking about here, potassium carbonate. So K2CO3. I say it again, K2CO3. So K is 39. K2 means 39 times 2. That means 2 atoms of potassium is present in that compound. So 39 times 2, K2. The next one is C. So 39 times 2 plus C is 12. That means plus 12. So I think they are putting the decimal point here. They are saying 39.1. So you can do it as 39.1 times 2. That will give us 78.2 plus the relative atomic mass of carbon, since it is K2CO3. So C is 12. That is 78.2 plus 12.01. That's going to give us 90.03 or 90.21. Okay, 90.21 plus oxygen is 3 here, K2CO3. So oxygen is 16 times 3, that is 48. We have 90.21 plus 48. So that's going to give us 130.21 atomic mass units. So that is it here. 138.21. Okay. 138.21. So please, are we getting it? Thank you.
Please, can you just explain it again, please? Just once. Thank you.
Okay. Okay. Okay, I've heard you. Okay. So I said this is the screen again. Calculate the formula mass of potassium carbonate. So you are going to write the compound out first. Write the formula of the compound out. So that is K2CO3. That is the formula. Relative atomic mass of these things are given to us now. So relative atomic mass of potassium is 39.10. That's 39.1. We said the formula is K2CO3. So potassium will be 39.1 times 2 because it is K2. That means 2 atoms of potassium are present in that compound. So K2 means 39.1 times 2. That is 78.2 plus CO3. So C is carbon. That is 12.01. So 12.01 added to that 78.2, that is 90.21. Added to O3, K2CO3. O is 16.0 times 3, that is 48. So add that 48 to 90.21. It is going to give us 138.21 at atomic mass units. So that's it. So the next thing, I don't want to calculate anything here. We are going to calculate this one too. So okay, let me explain this one to like this. The empirical formula obtained from a compound is this.
No.
See? Hello?
We are not serious.
You are not saying my screen?
Yes.
I don't understand though. I'm sharing my email.
Pin his screen. You will see it better. Pin his own screen.
I'm saying, I'm sharing my screen. I beg.
Okay, I've seen.
Yeah. I said the empirical formula obtained for a compound is C3H2NO2. The gram molecular mass of the compound. Please mute your mic. Mute your mic, please. The gram molecular mass of the compound. The gram molecular mass of the compound. The gram molecular mass of the compound is found to be 168 grams. Determine its molecular formula. So the molecular formula can be gotten from the empirical formula if the mass number is given. Osman. Oh, let me write this one out. I want to. Okay, I'm coming. I want to write I want to use pen. I didn't want to use the pen and biro and notebook before. Okay, so I'm unmuting my screen now. Okay, so I don't know if any of us has the formula with him or her. I have to ask the question with him or her. So maybe the person can just let others see it. So the question says this. It says, this is the empirical formula given. I've seen it. The empirical formula obtained for a compound is C3H2NO2. So, and the mass of the compound is 168 grams. So, this is it. Okay. Who's raising a hand? This is the empirical formula given. This one is the simplest formula for this thing. That's what they mean. The simplest formula. It is the empirical formula given, and they said this is the mass. If you are given the empirical formula and you want to calculate the molecular formula, you want to get the molecular formula from it, it is very simple. Just take a good look at what we have here. We have C3H2NO2. That is the empirical formula. So you are going to do, empirical formula times something will give you the molecular formula. So C3H2NO2 multiplied by X equals to the value of the molecular formula, which is 168. So now we are going to look for the mass of these ones. We know carbon is 12. So 12 times 3 plus hydrogen is 1. We're talking about the mass number. 1 times 2 plus nitrogen is 14. So 14 plus oxygen is 16. 16 times 2, all enclosed in the bracket multiplied by X.
168.
168. So doing the math, 12 times 3 gives 36, plus 1 times 2 gives 2, plus 14, plus 16 times 2 gives 32, all enclosed in X equals to 168. So adding this together now, we are going to have 84 multiplied by this X. That's 84X equals 168. That's the coefficient of X. Dividing both sides by coefficient, we're going to have X equals 168 over 84. So X equals to 2. So that's the logic. Now come back to the formula. This is the empirical formula. C3H2NO2 multiplied by X, which is 2. You're going to get the molecular formula like this. So, open the bracket. 2 times the 3 of this one. C6. 2 times the 2 of this one. H4. 2 times 1 of nitrogen. N2. 2 times 2 of oxygen. O4. This is the molecular. This is the molecular formula. So, any question? Any question, please?
We cannot see what you solved. Like your video is not. You didn't turn on your.
I think I turned on my video. What are you saying now? I turned on.
Please, can you come again? For us that are just joining, please.
I'll come again, but I turned on my video. So I'm coming again now. I said we have C3H2NO2, which is the empirical formula. So, and we have the mass given, which is 168. We are looking for the value of the formula, which is the molecular formula. That means the formula that will represent that compound itself, the actual formula for that compound. This one is a deduced formula. It is the simplest formula in which the compound can exist. So C3H2NO2 multiplied by X is going to give us that molar mass of the molecular formula given. They already said it in the question. So C is 12. That means 12 times the 3 divide it, or that is subscripted. So C3 means we have 3 atoms of carbon in this compound. So that is 12 times 3. Plus H2 means we have 2 atoms of hydrogen here. That is 1 times 2 plus nitrogen has the mass number of 14 plus oxygen has the mass number of 16, and we have 2 oxygens here. That is 16 times 2. All enclosed in this bracket multiplied by x equals to 168. Multiplied by x equals 168. So now we can do the mass now by adding all the things inside this one. We are going to get 84. So the 84 now with the x outside, 84x equals 168. Making x the subject and getting its value, x will be 2. So don't forget that this was your x before. Now come and use the 2 to represent x back. C3H2NO2 multiplied by 2 equals to C6. That is, you are expanding the bracket. 2 multiplied by this 3, 6. That is C6. 2 multiplied by this 2. That is 4. H4. 2 multiplied by this 1. This is ordinary 1 since there is nothing there. So that is N2. And 2 multiplied by this 2. O4. So this is the empirical formula, and this is the molecular formula. The empirical formula will show the simplest form in which it can exist, the simplest ratio, while the molecular formula will show the actual way the formula exists. That is the thing there. So please, any other question? Any question? Okay.
Sorry, please, can you go over again?
Please, I can't go over again. Sorry, I can't go over again. Wait, who talked? Who asked me to go over again? Person is not sleeping. Mohammed.
Yes.
Listen. I said we are asked to look for the molecular formula from this thing. We are given the empirical formula, and we are given the molar mass. We are given the empirical formula, which is the simplest formula with which it can exist. See, this is glucose, C6H12O6. If we take a good look at this thing, we can write it in another form, which is CH2O, by taking it to a simple form. This 6 here 1, 6 in 12, 2, and 6 here 1. So we're writing C1H2O1. So this simple formula is known as the empirical formula. Why this molecular formula? This formula that actually shows, please wait your mind. This formula that actually shows what the compound is. This formula is known as the molecular formula. So that's that. So this is the empirical formula given to us. That means the simplest formula. And we are given the mass number or the molecular mass of that thing to be 168 grams. So writing the empirical formula out, we are multiplying it by something to give us the molecular formula. So let the something be X now. C3H2NO2 multiplied by X equals 168. So we are looking at the mass numbers of these things. So the mass number of carbon is 12. So 12 times 3, because we have 3 atoms of carbon here. Plus hydrogen, which is 1. 1 times 2, because we have 2 atoms of hydrogen here. Plus nitrogen, which is 14. 14 is there. Plus oxygen, which is 16. 16 times 2, because we have 2 atoms of oxygen here. So that gives here. So all equals to 168. Doing the mass here, we're going to have 84x equals 168. And x is going to be equal to 2. So now don't forget that you wrote something here. C3H2NO2 multiplied by x. So C3H2NO2 multiplied by x, what is the x? 2. So you are going to get the molecular formula from this. So use the 2 to multiply this 3. That becomes 6. C6. H2 to multiply this 2. That is H4. 2 to multiply this 1 behind, subscripted for N. That is N2. It is that same thing, that same one we used that day. The Chm191 2017. It's the same one we used. I think page something. I'll show you the page later. My screen is not, but you can keep going. You will see it there. I jumped some calculations because I didn't want to touch them before. I explained to you now. So O2 multiplied by these two now becomes 0.04. So this is the molecular formula of the compound, and this is the empirical formula. This is what they are looking for in that question. This is what they want to hear, they want to see. So I want to open back to the question. So the next question here says, a substance with a pH value greater than 7 and less than 10 is what? A substance with a pH value greater than 7 and less than X is what? So,
Weak base. It's weak base.
Big base.
Somebody said strong base, somebody said weak base.
Weak.
Weak base.
Weak base.
You said it is what?
Weak
Greater
base.
than 7 and less than 10. So it is a weak base. That's right. Okay, the next question is, if actual yield of ester is 32.7 grams, the theoretical yield is 35.1 grams, what is the percentage yield of the ester? So formula for percentage yield is always equal to, what's it called? The actual yield over the theoretical yield multiplied by 100. That is percentage yield. The question is from 2017 Chemistry 191. It has been sent several times into the group. So we said if actual yield of an ester is 32.7 grams, please mute your mic. And theoretical yield is 35.1 grams. What is the percentage yield of the ester? Percentage yield, the formula for percentage yield means the actual yield over theoretical yield. Actual yield is the thing you calculated in the laboratory yourself, but theoretical yield is the thing you predicted before doing the experiment. So percentage yield equals to the actual yield over theoretical yield multiplied by 100. So that means it is 32.7 divided by 35.1 multiplied by 100. Let me write it out. They said the theoretical yield is gotten to be 30. The actual yield is gotten to be 32.7 grams. 32.7 grams. And the theoretical yield is gotten to be 35.1 grams. So percentage yield means actual yield over theoretical yield multiplied by 100. What is the actual yield? 32.7 over what is the theoretical yield? 35.1 multiplied by 100. You should get 90 something. So anything you get there will be your answer. Anything you get there will be your answer. That's for that.
In percentage.
Yes. In percentage. Anything you get there will be your answer. The formula for the theoretical yield is equal to the formula for the percentage yield is equal to the actual yield. That is the yield you got after your laboratory experiment over the theoretical yield, the yield you predicted before doing your experiment, multiplied by 100.
Thank you.
The next one is
93.16.
Okay. That is the answer then. The next one is, I'm coming, the thing is loading. The formula obtained by multiplying the number of each atom in the empirical formula by n is called what? We did a mass now, right now. We multiply the empirical formula by x, right? So what formula did we get from that?
Molecular formula.
Thank you. That is the answer. So this one says there are dash types of titrimetric analysis.
4.
There are 5 types.
There are 4 types of titrimetric analysis.
Thank you. So in titration, experimentally determined stoichiometric point of the titration is referred to as what? In titration, the experimentally determined stoichiometric point of the titration is referred to as what?
Equivalent point.
Equivalent point.
Equivalence point.
Equivalent point.
Is it the equivalence point?
Yes.
Yes.
Are we very sure of that?
Yes.
No,
What do you say?
it's endpoint.
And you are both. Meet your mic.
Mute your mind if something like this is happening, please. In titration, the experimentally determined stoichiometric point of the titration is referred to as
Endpoint.
Endpoint.
Do you have anything?
yeah, I don't know. That's why
It's endpoint.
If you can't have end point, it is called end point.
It's not endpoint. So
It's equivalent points as well.
equivalent point.
I don't want to believe it is endpoint. I'm thinking of match point,
Equivalent point. Oh.
equivalence point.
Equivalent point. Yes.
What is an equivalent point? An endpoint.
End result.
I'm coming. I have my course material. I've brought it out. Let me see if I can skip through it and get it. What's the question again, sir? The in titration, the experimentally determined stoichiometric
Equivalent
point.
point.
This one is not easy to see.
Then for the endpoint is
See, bro, it's valence points. It's the valence points. They said it in the practical.
Valence point.
Yes, that's it.
Which one are you? I mean, I cannot hear something like this and just accept now. Okay, I've heard
Okay,
it.
this is the definition for equivalent point.
Thank you.
Are you checking it?
I thought you wanted to read it out.
Okay, say equivalent point or stoichiochemistry, 3 point of a chemical reaction is a point at which chemical equivalent quantities of reactants have been mixed. I don't know if you get that.
I got it.
For
Now does it?
an acid-base reaction, the equivalent point is where the moles of acid and the moles of base will neutralize each other according to the chemical reaction.
That is the end point then.
That is not the end point. That
What's the
that
end
point is trying to tell you that equivalent point is a point whereby the chemical, that's the hydrogen ion in that particular element has been met, it has been broken down, but the end point has not been ascertained. So the point of completion, that is what you call an end point.
Okay. Okay. Let me try to see if I will agree with you.
Sorry, can you read that question again?
Okay. In titration, the experimentally determined stoichiometric point of the titration is referred to as. It's not something else decide on it. The question is logical itself. In titration, the experimentally determined stoichiometric point of the titration is referred to as.
I know the equivalent point, but to describe it, I don't know.
It's the thing inside the course material.
the thing is equivalent.
Okay.
It's no
Maybe
This thing is that I have tried it before and this equivalent point. So from now this thing, that is what they put there as the answer.
okay.
I don't want to put as the answer.
That is what they put there as the answer. I've tried it before.
Even the
I've also done this.
Okay, if that's the case, no problem. You guys can take it out with them.
Take it as what?
Take it as the thing you chose now. I don't know what you are choose. I don't agree with any of that. Anything you do, take it as it. It's just a mark. Okay. The next thing I have here is in a standardization titration involving hydrochloric acid and sodium carbonate. The student recorded the following results for the volume of hydrochloric acid used against 10 milliliter of the sodium carbonate solution. 15.60. This is the values, that means the titer value of the acid. 15.60. Concentration of sodium carbonate is 0.75 mole per dmq. Everyone will solve this. I won't solve anything.
Yes.
Sorry,
So
please, can I see the question? I'm not seeing the
I'm
question.
going to share my screen. I beg.
Okay,
Don't
okay.
disturb me this night. Alima, Abiu, Minat. Don't disturb me, please.
I don't understand. Did I talk?
Ọ̀gá Adé máa kanra mọ́ àmì náà nà.
Okay, no be. See the person as the person they give me voice. Only I will not see the screen. Not let's happen now.
I'm the one.
The one who
Okay,
I
just
not.
put out this thing.
Use it. Okay. This is the question. So everyone solve. We've done some things involving this other. Are we all seeing the question now?
Yeah.
Yes.
So you write your equation of reaction first, and you get the average volume of the acid used. Now you see a V over N over C divided equals to N over N.
This milliliter is going to be divided with 1,000, right?
No, don't worry. Wait, volume of hydrochloric acid used against. No, don't divide it. Let it be volume of the base used, VB. Don't divide it. Don't bother to divide anything. Just take it as VB straight. 10 milliliter. This one is not showing in my screen like this.
Hello?
Yeah.
Can you hear me?
I'm hearing you.
Okay. You know why I'm divide it? Can you hear me?
I'm hearing you now.
The molarity is expressed in mole per dm cube, not in mole per milliliter cube.
Okay. Let me tell you something.
Okay.
The thing you are looking for here is the concentration of HCl solution.
Yes.
So it's a mole per dm cube. You are looking for it. So the thing you are saying that 10 milliliter, even if you divide it by 1,000 to change it to liters, you will eventually cancel the both of them. I think something like this wanted to happen when we had the practical this. I just told the guy, even if you divide it by 1,000, volume will still cancel volume because there's volume at the right hand side.
Yes.
There's volume at the left hand side too. So don't let it disturb you. It is only a good waste in the exam. So let it be your VB. So the thing you are going to get as your average volume of acid used from this information is given 15.60, 14.50. This ones I can see the points that are close. So 14.50 is close to 14.70 and close to 14.30. Take the three of them. And calculate their average. You are going to get the average volume of acid used by that. So is that of average volume of acid that will be VA, while the 10 mil that was given earlier would be the VB. Write your equation of reaction out and balance it. You will get your NA from the equation of reaction and MB from the equation of reaction. You are given the PB to be 0.75 mole per dmq. So calculate the CA.
Okay.
I'm going to write the equation of reaction out now.
Okay.
I'll write it out now. They expect you to know it, sir. I'll write it now. This is the equation of the reaction. This is hydrochloric acid, that is HCl, and NA.
pay me for this thing. I don't drive out to come and stay like this.
What do you say?
I'm waiting at the try do since morning. I ain't done the do.
Hydrochloric acid and Na2CO. Na2CO, yes. So hydrochloric acid and Na2CO3. So that's sodium carbonate. So the product is going to be, actually, it is a reaction of two steps, but let's take something straight. So the product is going to be NaCl
plus H2O.
H2O plus CO2. These are the products given. The products got in there. So let's balance the equation first. We have two chlorines here, one chlorine here, but one sodium, two sodiums here. So put two at the front. The two has affected the chlorine, and we have two hydrogens here. So 2:1. So Na equals to 2 and Nb equals to 1. Na equals to 2 and Nb equals to 1. That is what you got here. Na equals to 2 and Nb equals to 1. So Va is what you get by using the average. Vb is gotten to be 10 milliliter or given. Cb is given to be 0.75 mole per dm3. You have to look for Ca. So your Va is going to be the V1, V2, or Va1, Va2, and V3 divided by 3. You get your average value. I'm going to show the question again. Okay, Miss Amina, what do you get?
Hey, subhanallah.
I thought you said you are done.
Yes, so I'm done with the calculation.
What do you get?
I got, wait a minute, 1.03 ml.
1.03 milliliters.
Yes.
Calculate the concentration. Concentration. I think your value is wrong, right, but your unit. Concentration in mole per dm3. It should be milliliters. Molar. You understand?
Okay, let me cross check this thing.
No, your answer is right. It's probably right. It is probably right. I trust you. But that thing, I'm saying your unit. I think you made a mistake.
Yes,
ml.
answer is right.
The thing is that this is the second time for me to do the calculation on that list. So I'm guessing the same thing is ml, and I don't know whether I'm correct or wrong.
You cannot get your more. You are looking for concentration, right? So you yourself should know that you are not getting. You are not getting
Yes,
it.
yes.
That's the unit of volume. Milliliter. Liter is volume.
Wait,
This thing you are looking
you know
for.
that question on the question, what they gave was concentration of hydrogen chloride is what 10.00 ml.
In the question, let me show you the question. It is volume of hydrogen chloride against the volume. It's not for the volume of hydrogen chloride. Hydrochloric acid. It's not even chloride. It's hydrochloric acid. Don't be confused. Hydrogen chloride is a gas. Following results. Read the question very well now. They owe you.
But I don't understand this question very well. They said the volume of
Maybe I should
hydrochloric
solve it. I will solve it now.
acid.
Okay. Let's be together then, everyone. This is the solution. This is the solution to the question. I have the where are the written parameters? I wrote the parameters out now. So these are the parameters. I wrote them out now. So I already have my balanced equation. I already have this. So I'm going to write the formula I'm going to use. That is CA over CB equals NA over MB. Don't forget, I'm looking for CA. That is the concentration of the acid, which is hydrochloric acid. So Ca equals to CbVbNa over VaMb. Naomi, anything? Naomi,
I can't see your screen.
okay. You should see it now. This is the formula. I have my informations written down here. This is the equation of the reaction. This is the number of moles of A. That's number of mole of the acid from the equation of the reaction. That's 2. Number of mole of the base from the equation of the reaction. That's 1. So I have my volume of the acid. Please mute your mic. I have the volume of the acid, which is volume of the acid was given to be. Okay, you guys calculated it. Please, what do you get? Miss Amina, what do you get? You have an average volume of
Now on,
what do you call it?
I got
1.03
ml.
Eh? 1 point.
03 ml.
3 ml.
It can never be.
No, it cannot be 1 point.
Let me see. We have 14.5 plus 14.7 plus 14.2. Are you with me? So maybe 14.425 or 475. Please add 14.5. We are given the volume of the acid, the first titer value, the second titer value, the third titer value, and even the rough titer value. So we are taking the one that are concordant. That is 14.5, 14.7, and 14.2. They are close to each other. So add the 3 of them together and divide them by 3. You are going to get the average volume of acid used in the titration. So 14.5 plus 14.7 is going to give me 29.2. 29.2 plus 14.0 will give me 43.4. If I'm right, 43.4. So now if I divide the 43.4 by 3 now, so what would be my answer?
14.47.
14.47. So that's the average volume of the acid used.
Yes.
So let's see, I'm writing it out now. What is it? 14.47 is the average volume of the acid used. So ml, milliliters. So I'm looking for Ca. This is my screen, my paper. So Cb is given to be 0.75 times what is Vb? That is 10 that was given before. Times Na is equal to 2 over Va is gotten to be 14.5 or 14.47 right now, multiplied by Nb, which is 1. So please, let's do the math here. Anyone with a calculator to do this? That is 7.5 times 2. Okay, that's 15 divided by 14.47. That's 1 point something. Absolutely, maybe 1.1 something or 1.2. 0.75 times 10 times 2. So that's going to give me 15. 15 divided by, okay, thank you, Mr. K. That's 1.036 moles per dm cube. Maybe I can say 1.036 moles per dm cube. So that is, what do you say?
They didn't. I'm seeing 1.0366.
Hello. I did it today and I got it. But what I did was, what you are explaining now makes sense to me. I added values divided by 4.
All the values
All the
divided
values.
by 4.
And what you are saying now makes sense to me. It's not supposed to be all the values.
Thank you. Thank you for understanding. It's not supposed to be all the values because the values are used according to the concordance.
Yes.
How do they concord with each other or concur? So because that you can see the first one, that is the rough titer value, 15 point something, and all others are 14 points. So absolutely just use those ones as are close.
Yes.
Yes, sir. So
If you
because
add that, you will get the answer, but it's not supposed to be like that.
Yeah. Okay. Miss Amina, you were saying something. Any issue about the answer we got there?
Sorry,
you don't approximate. What you have 1.0066. No approximation. Maybe 1.0. How many decimal places?
Maybe by approximate, maybe now approximate to 1.04. Maybe.
Now, let me chip in an idea there too. Today, when I got my answer, I put it in 2 decimal place. I got one, maybe not this question, one of the questions I got 0.0.72, and they got 0.716. You know, they didn't approximate that 6 to 2, and they didn't give it to me. They put their own 0.71166. I put my own 0.72.
You know, sometimes this now too, we have to be lucky. That's it. We are not wrong. We are not wrong. We just have to have luck. That's all. I hope we are lucky. I hope
Nonsense. Look.
It's nonsense.
Hello.
Oh, God.
Because it's not all about reading.
Can you imagine? You go spend time to read only for you to go to find luck for exam hall. Which kind of rubbish be that? That's school that one.
It's not about
but how about someone? It sounds somehow, but is that not the fact? That's the fact now. See
That's the
now,
fact.
person no go even read for exam. If we are reading now, we are reading for some other motives. We have some other things that's making us to read now. Because the exam is out of it. It's out of it. But they vex myself.
Yes, now.
Since ever since I started it now, this is the big disadvantage I'm saying there. A very big disadvantage. It's going to have a bad print inside one certificate now. Like, this that one will come to the person no know. The thing they vex me that they remember.
Excuse me.
Just be like,
Hello.
yeah.
Hello. I want to ask something from what you picked out. You said your CB, your CA. That's what we are looking for. Then CB is the average title value.
Auntie, I said, the only thing I'm hearing is CV, as if you want to apply for work. Please, maybe you should just mute it and do it again.
I said, are you listening?
I'm listening now.
Your CB is your average title value.
No, no.
I mean,
please let him answer so I understand.
CB, your CB is the concentration of the base. Yes. CB. C starts from concentration. Average title value is the volume of the acid used. The volume of the acid used is average title value. And average title value of the acid. So it is the volume of the acid used. So C represents concentration, V represents volume. So VA, A represents the acid, B represents the base. VA is the volume of the acid used, VB is the volume of the base used, CA is the concentration of the acid used, while CB is the concentration of the base used.
Okay.
Okay.
Thank you, Mr. K. So my approximation, get 1.0 formula.
Next question, please.
Okay. I'm going to share my screen again then. I'm coming. Okay. That's all. The number of gram equivalent weight of solute in 1 cubic decimeter of solution is. Listen carefully to this thing. They said the number of grams. Okay, I'll send it to you now, Mr. Abigail. The number of grams. I'm coming. Let me read the question out first. The number of grams equivalent weight, gram equivalent weight of solute in 1 cubic decimeter. That means gram per decimeter cube. Grams per decimeter cube. So what is that thing that will have the unit of grams per decimeter cube?
This is that's normality.
Thank you very much. Normality, that's mass concentration. Grams per cube. Thank you very much. So I'm coming. I want to share something. I don't know if there's someone else that can share his or her own screen. So I quickly want to share something to someone now. If there's someone that can share his or her screen, I'm in page 7. The number of grams. So we just finished that one now. Stop sharing. Okay.
Many hands are up. Oh, is the
I'm
hand not tiring? You're not tired.
no. It's hands that they've raised up since we've actually attended to them.
Okay,
So please,
sorry for taking us back. Oh. I have an observation on that percentage you calculated before, because I did that same thing in the mock test I took this afternoon, and that 93 points, that they didn't times their own by 100. That's the actual yield over theoretical yield. They didn't times their own by 100. The answer was just 0.93 something like that. But we now are timing by 100. Like, is it that their own answer is wrong? Abi, their question that is wrong? Abi, I don't understand.
bro, trust me. We are all brains here. Everybody is working here. Trust me, it's the answer that is wrong. They are stupid. The percentage, should be now. Percentage should be expressed in percent.
Yeah.
Yes.
We don't just have choice. That's why I said it's luck. It's luck. It's even vexing.
That's it.
I'm all aware of buying you.
Sorry, please. What year
funny,
summary
man.
are you guys solving?
It's 2017.
2017. Okay, thank you.
I want to share this. I'm coming. Please, is there someone that's sharing the screen now? Sharing his screen now. It's Abigail. I'm looking for it. I haven't seen it. Is there someone sharing his screen now? I'm quiet doing something now. Oh, I'm not seeing this thing. Who is sharing his screen? Nobody.
I no get the question. If not for share screen, I no get the question.
Okay, I've seen it. Yes. I've sent it to you. Okay, I've sent it to you. Okay, now.
Bro, I message you for WhatsApp. Oh. May you help me send the questions. But if you know if you do it now, if you know if you do it now, if you do it later.
Thank you. Okay, thank you. The person that's sharing is on screen now. Oh yeah, where is it? Okay, let me share my screen. So we'll continue with the question now. So the next question says, the next question says, there are different techniques for determination of an unknown sample in titrimetric analysis.
4.
There are
Three.
three. Why?
Oh, guys, listen.
3.
Is for
Somebody says
No. We are all learning. Why is it 3? It's not fight now.
Direct, indirect, and direct, indirect. What's the third one? It's 3.
I'm back.
You don't have evidence.
I'm back.
You are
Yeah,
doing the 3.
thank you.
You don't have evidence. You don't have evidence. You are doing 3. You explain tire. You say direct, indirect. Yeah, Joe, explain.
I'm back.
I'm back.
Okay.
Okay.
The direct is the titration of acid and base. That's a mixed acid into base. The indirect, the back. So
Okay.
I forgot to.
Okay.
But it's
No get evidence. No get evidence. You explain tire. Okay. I think it's the 3. I think I agree with you.
that's the correct answer. It's 3.
I actually played 4 before, but it is direct, indirect, and back titration. So when it is direct titration,
Yeah.
so the standard solution directly reacts with the substance being determined. That's when you have the base as the standard solution and the acid you want to determine its concentration. For the back titration, that's the measured one standard solution is added to the sample. You understand? So as for the indirect solution, so it doesn't react with it straight, but it reacts with another thing that produces it inside it. So that's for that. The next thing is, the next question will be the solution whose concentration is known is called what?
Saturated.
Standard solution.
Now standard solution, no standard though.
I wanted
Mr. Chidi. Please, the radio is disturbing us. Who is playing radio?
Is Mr. Charles.
Oh. Okay, is there any question? So they said is a what's it called? A solution with a known concentration is known as
Standard.
But in this place now, part of what I've seen, they are calling it titrant. This is it. See?
Tighter value.
Titrant.
It's not tighter value now.
It is also known as titrant.
The answer is titrant.
Titrant or standard solution.
Titrant.
Okay. Let me now
It's
ask, what is
tighter value.
No, not
Titrant.
Can be titrant, can be standard
Okay,
solution. It's the same thing.
Oh, titrant. Okay.
Please help us stop this radio. It is disturbing us, please. The radio, help us stop it, please. Okay. So what about the solution with an unknown concentration? What's that one called? When the solution with known concentration is known as a standard solution or titrant? Anyone with the answer?
no standard.
That's right. But as you can call that one titrant, what other name can you call the other one? Okay.
One more by you.
It is analyte.
Sorry, I don't get what you said.
Like, you can call a solution with a known concentration a titrant, right?
Sorry, I didn't get what you are asking.
I said a solution with a known concentration, you can call it a titrant, right?
Yeah.
Standard solution. So now, a solution with an unknown concentration, you can call that one a solution with an unknown concentration. So, or analyte, A-N-A-L-Y-T.
Okay. Analyte.
Yes.
Cool.
Who's playing this radio? Who's playing radio? The radio is disturbing me. It's disturbing my own.
You are not a kid now.
No, maybe it was a mistake. Okay. The next question now. So I said it is analyte, A-N-A-L-Y-T-E, a solution without a known concentration. That's like the acid we are looking for its concentration now will be the analyte. The concentration of the pure HCl. The concentration of the pure HCl used is 111.7 molar. If 20 cm cube of V1, 20 cm cube V1 of 11.7 molar of C1 of hydrochloric acid is diluted. What we have here is that we have V1, which is 20 cm cube.
Yes. C1 is 11.7.
11.7 mole per dm cube. We have V2, which is 250 cm cube. 250
cm cube. Oh no.
So makes it to the subject. Makes it to the subject. 11.7 times 20.
Times 20 over 250.
That's 23.4 divided by 250.
Yes.
Yeah.
That's not fine.
That would be 0.936 more per dm3.
Thank you.
Per
Yeah.
dm3.
They diluted it. What is the name of that formula you used? I think I mentioned it. If you knew it, if you had it, rather. The formula you use, C1V1 equals to C2V2. Okay.
I don't know the formula name. Let me the formula name. Oh, no.
It is dilution formula.
Okay, dilution formula.
Not showing like this. I want to minimize. It's not minimizing though. Mm-hmm. I never seen my screen. The next question is the procedure by which a solution of known concentration is added to another solution until the chemical reaction between the two solutes is complete is what? What is the procedure?
Titration.
Titration analysis.
Volumetry analysis or titration.
It's added to another solution.
It should,
What do you
I,
say?
titration is under
Titration
volumetric
analysis.
analysis now.
Is titration analysis.
Titration of
Trigonometric
volumetric
analysis.
analysis.
Sorry.
Trigonometric
Trigonometric
analysis.
analysis.
Okay, this one is titration, the procedure by which a solution
Uh,
of no concentration is added to another solution until the chemical reaction between the two
okay,
solutes
sure.
is complete. Maybe we all know titration. Please let's mute all
Yeah.
the
Trigonometric
let's mute
analysis.
them. No, it's not gravitational or gravimetric rather. It's not gravimetric analysis. It is just titration.
Trigonometric.
Okay, you are calling it titrimetric. Okay, you are right. Titrimetric analysis, yes. So it is titrimetric analysis. But I don't know the one they will be choosing though. Is it titration they will choose or that titrimetric
Yeah,
analysis?
trigonometric analysis is the answer.
Titrimetric, okay.
Yes.
Okay. From the equation HCl 2HCl plus CO2 plus H2O. Given that 2 moles of hydrochloric acid react with 1 mole of washing soda, what was the concentration of the acid? What was the concentration of the acid? We have the number of moles here. We are not given
Yes.
any volume. So we are looking for the concentration of the acid. We are not given the volume. Is it possible?
Did they give us molar mass?
No. Normally, we can calculate the molar mass by ourselves, but
Yes.
we can't get information from the molar mass. So except if you want to say their volume is constant. So
Yes.
now CA over NA. CA over NA equals to CB over NB. Who will try the formula first?
And can the moles be equivalent to the volumes?
No, I'm trying to say the volume is constant because they are not giving us. Maybe I believe this question is wrong. That is not complete. But I'm thinking if we can get
I'm
something.
still suspecting that that we have solved something like this before. That was the first time when you were balancing an equation. Yeah, we had to balance this similar equation too.
No.
I don't
If
know.
we
Maybe somehow this question is connected to that one.
they will now bring it like this. Is it theory we are doing that they will say answer this one with AD and O?
You know that these people, they are people of science and wonders. So
Yeah.
Right, that one can never be possible. Well, if it is even possible, it can be possible. Wait, no, they don't have sense.
because if you see the question say what was the concentration of the acid? Well, that's what was that means
Yeah.
calculated it before.
Let us go upstairs. Let's go and look for the information. What was the concentration of the acid? So we'll just take the concentration of this one and take the volume from this one. So maybe it will be if it is the same answer with what we got there. We got 1.04 there. Here they are getting what? They are getting what? Where is the question? 0.103. About this thing, Jerry. A different thing. You just fail this one in peace and leave. If you see any question like this, just
0.1.
how do you get 0.10?
Yes, because I didn't get the calculation.
I'm thinking something that the volume is constant, but we don't have any concentration here too. So the question is not complete. We can never get an answer from this question provided. That is it. I never get an answer from it.
I just checked. It's the same answer for that one before and this one is the same answer.
Okay, thank you, Jerry.
They
So
are connected. I
you
just
better
checked.
you plan
So
something
this
like
question
this.
is
So
actually connected to that one.
Why would they
And they didn't even signify that like maybe
They want it to
yes, now
if
even like
you guys want to vex, go and it's not this group that will be vexing. Go and vex for now, please. Yeah. Okay, the next thing. The next question is the label on a stock bottle. I've received question like this several times. If don't pass 10, solve this thing for me, solve this thing for me. Like the label on a stock bottle of an acid. Upon say I don't solve and I don't know the answer of and I don't solve. Label on a stock bottle of an acid reads 56% by mass and 1.25 specific gravity. If the molar mass of the acid is 56, find the volume of this acid that is required to prepare this. So that means you are going to find the concentration of the acid first. So now we are now going to
You find the volume first.
This
You
thing
find
is a
the
long
volume
process.
first.
You are not finding the volume. To get the volume, before you get the volume, now, you must get the concentration first in moles per dm3. So because of this volume now, we are going to find three things. The first one is concentration in grams per dm3, so as to get the concentration in mole per dm3. So now after getting the concentration in mole per dm3, we'll now multiply it by the V, will be equal to the second thing, that is C2V2, using the dilution formula. To write all these things out now.
That's 700.
700 grams. Thank
Volume
you.
is
For everybody.
700.
Yeah, that's the 700 grams
dm3.
per dm3. That is concentration in grams per dm3. So in most
That's volume. Then you
will be
substitute for the
700.
distance, which is 2.
In
Its
most per
concentration is
dm3.
2.
What are you saying? What do you say?
I said the answer there is 700 dm cube. And the concentration is 2.
700. Okay. No. Well, I said we are
Yes.
asked to look for the. We are now. We are asked to look for. Look, are you seeing my question?
Yes, I've seen
We are
it.
looking, find the volume of this acid.
Yes,
So
that's
you
what
are
I'm
looking for
telling
the
you. The
volume of
volume
this
is
acid.
200.
That 700 you got. Are you with me? That 700 you got is only the mass concentration.
Yes, that's mass concentration.
Start getting the mass concentration.
You now just calculate. These people are mad.
After knowing the molar concentration, you now go C1 V1 equals to C2. So C1 is the
I
molar
think
concentration.
I think you still have to convert that this thing, that grams to molar mole per dm cube. That 700 grams to convert it to mole per dm cube
That's what I'm saying.
before you now do C1 V1.
That's what I'm saying. Maybe we should just do it together, Jerry. All these people are vexing person. My book self don't. You don't finish. Don't get shit on paper again. Yeah, let's do it. Let me write the information out first. I have the percentage by mass. I want to write it out before minimizing to take it to video. Now you guys should also write it out. Percentage by mass is 56%. Specific gravity, it is just relative density. Relative density is 1.25. It is grams per cm cube. Normally, relative density doesn't have units, but it is grams per cm cube, grams per cm cube. Molar mass is given to be 56. So we have the V2 given to be 250 cm cube. We have the C2, 1 mole per dm cube. So we are looking for V1. But to get that V1, we must get that C1 first. And to even get that C1, we must get the concentration of the acid in grams per dm cube first. So I'm going to show my screen now. These are the parameters I have. Okay. These are the parameters I have. Are we seeing it?
Mm-hmm.
This thing now, it is percentage by mass is 56%. So that means it is 56 grams out of 100 grams, right?
Okay.
So the specific gravity is 1.25 grams per cm cube. That is 1.25 in 1 cm cube. So it can be to dm cube now. You have to change it to dm cube. So it will be 1,250. That is multiplied by 1,000. 1,250 grams in 1,000 cm cube. That is 1 dm cube. That is 1,250 grams per dm cube. We can say this is the mass concentration, but it's not possible because they said the percentage by mass is 56%. So since it is 56%, we'll now come here and say 56 times, because it is 56%. Adibin is 100% now. We'll say this is the grams per dm cube. So 56% times 1,250 all over 100, because 56%. So doing the mass here, we are going to get 700 grams per dm cube. This is the concentration of acid in grams per dm cube. That's normality, mass concentration. So now we are looking for the concentration in mole per dm cube first. So that is Ca, concentration in mole per dm cube, equals to concentration in grams per dm cube over molar mass of the acid. If you don't know the molar mass, we come out to write it out. Okay, we are given molar mass. We are given the molar mass to be 56. That's good. So what is the concentration in grams per dm cube? That is 70 over molar mass is 56. So this is going to be 700. Thank you very much. Thank you very much. 700 divided by 56. 12 point something.
12.5.
Thank you.
12.5 mole per dm cube.
Moles per dm cube. Now we just got the miss that was talking about the thing now. So that I said 700. So please, are you getting it now? We are getting the concentration of A in moles per dm cube now. That is Ca. So now using the dilution formula, CAVA equals CBVB. We are looking for the concentration, the volume of A. So volume of A, that's the volume of the stock solution, VA, equals to CBVB over Ca. What is the CB? Concentration of B. CB is, we were given, I think it is 1 mole per dm cube. 1 times, what is VB? That's the volume of the thing we are producing, or V2. We can call it C1V1 equals to C2V2. It's the same thing. So it is 250 all over, what is the concentration of A gotten? That is 12.5. So 250 divided by 12.5 should give me 20. Right?
To give you what?
20. Is that also? So 20 cm cube.
Actually, this answer is correct, but these mad people use 2.0. I don't know why.
2.0 is the answer.
System, they have brain.
You can never be 2.0, even with normal. With normal.
Concentration is 2, not 20.
Hello, madam. Are we fighting? Be polite, please. We calculated everything together right now. Why is it 2? Please explain. Please explain. Why is it 2? How is it 2? Please speak out.
We're going to use C1, V1 equals to C2 and G2.
Okay.
So now you see your C1 at 12.5.
Yeah, I've changed it. C1, V1 goes to C2, V2.
Is that what it is?
C, 12.5. That is C1. Right?
Are you listening? Your V1 is unknown. Then your C2 is 1.
Yes.
Your volume is 250.
What is
Then
my volume is 2?
It's 2 now.
Yes. Yeah, no, 2, okay. 250 divided by 12.5. Maybe you should press your calculator.
When you substitute it, that's 2. 2.5 times V1 equals to 1.5 times 250, which is going to give you 25 over 2.5, 12.5. This should give you 25 over 12.5, which is 2.5.
I think this person is reading from the course material, because even the course material is wrong.
Don't bother to
Yes,
don't
what
bother
I
to
want
That's
to
the
say that the
don't bother
course
to execute.
material they omit that is zero on 250. And the thing is that someone told me that
Exactly.
course material is what they need. So they use the course material to sell the system.
That's what I said. If you guys noted or noticed what I wrote, oh, pressure Tiwa.
Sorry,
Pressure Tiwa. Pressure Tiwa.
Wow.
Calm down.
Pressure Tiwa. If you guys noticed what I wrote, I said, me, I'll just use scope to cram this stuff. I know what I'm going to do, but I only cram the answers and enter the exam hall.
Hmm.
That's it.
yes.
Oh,
I'll
sorry.
cram the
Sorry,
it's wrong.
sorry.
Since
Please,
that's the
can I
answer,
say something, please?
say,
See, it is very good that we're even doing this thing. That has been my decision all along. That's why I asked earlier that which of the summary are you guys treating when you said
okay.
2017? Because several people have told me that they use these course materials to set the questions. And most of the time when you're solving these equations, their answers are wrong. Even in the
Wrong.
TMAs, if you do your TMAs yourself, you understand. So
Yes.
it's just exactly the way they have it. This particular equation we're solving now, I'm on the same page on the course material. Everything is just wrong. Like I'm
It's not
confused.
wrong. It's correct for their own
How is
side.
it wrong? If you say it's wrong,
It's
you
just
tell
the
us the reason
final
why
answer.
you
The
said it's
final
wrong.
answer is wrong, but the process is the same thing.
The
They got
process is the same thing,
12.5
but
more
the
per
end
DM.
answer is wrong. Yes, it's the same C1 V1 is equal to C to V2.
That's it. So please,
Just
I
like
will
you
implore
said, it's
you.
just better to just cram most of
Please
these
God will help
answers.
us.
I will implore you
Sorry,
guys. Let us
but
all
on this mock, the answer
listen
is
everyone.
12.5. Okay.
Listen everyone. Please let's all practice the mock exams. Let's practice the mock. Use the mock to know the answers. There are some of the questions that
Exactly.
will
I
get.
think that's best.
Correct.
That is
Exactly.
the
It's
best.
on the mock here. It's showing 12.5 more per DM cube.
If that is what they get in mock, I beg cram it. That's what
That's
they
it.
get.
So
On the mock, this particular question on the mock is 2.0. I did the mock
It's
as well today.
2.0 for
It's
chemistry.
2.0, it's not
That's
12.5.
why I said you see that it's 2.0 because even in the mock it's 2.0. Not 20.
Yeah, that's because they took it from the course material. It doesn't mean it's right actually, but because it is now, according to now, it's right. But according to the original chemistry, it is not.
There is now chemistry. What do you that's bad. See, I
Better
can't
you
wait to
give
get
them
it.
what they have, or give
Is it not the
them
same
what
thing
they
you
give
did?
you. Don't change it. Or don't use your
You
word.
did
Don't use your brain.
one time
Give them what they
250,
give you.
right?
Then you get
Divided
the
by
exam.
12.5.
So Auntie, it's the
Is
course
that what
material
you still did?
you are using course material to argue with me. We are doing our own process here.
I'm not
Just tell
using
us
cost material.
we got
Which
our
one is
own
this
course
cost
material.
material to write? I've solved that question several times. Let's
Please
go to the
calculate
next
it.
question.
250 divided by 12.5. Calculate it by yourself and you see it.
Now, is it not 250 divided by 12.5? It is 20. Ah,
Give
So
me calculator
anybody
there.
that is not supporting,
calculator. This thing is calculator. 250
anybody
divided
that
by
is
2.5. It's not 250 divided by 125.
twenty,
It's not 250 divided by 125. It is 250 divided by 12.5. It's absolutely 20 now. I'm going to go to the next question. I'm not going to give my
Let's go to
pattern.
the next question.
because this, please let's continue.
And now Monday, Monday. So this one is 3.47 grams sodium carbonate was dissolved in a 250 milliliter standard flask. What is the concentration of the resulting solution? The concentration of the resulting solution in grams per dm3. Just take the over mass over volume in dm3. So volume in dm3 will be 250 divided by 1000. That's 0.25. So 3.47 divided by 0.25 is what? 3.47 divided by 0.25.
13.88.
13.88.
3.88. Thank you. See, the label on the stock,
I think we still
It's
have to convert it to molar.
13.88.
we did convert it to molar. We converted it to molar. See now, how do I know? How do I know it is a molar they want it? How? Now let me get basket. I won't cry. See now, this thing is vexing someone. Like, oh God. Okay. The next thing is the label on a stock bottle of an acid reads 56% by mass. This is the question we did the other time.
It's the same question.
We've calculated the mole per DMQ before even using it. The residue of a chemical reaction is allowed to cool in any person?
Desiccator.
Desiccator, thank you. They said in this equation, sodium bicarbonate.
I think you have jumped one question or you left it like that.
The residue of a chemical reaction is allowed to cool in a desiccator. In a desiccator. That's the work of a
Excuse me,
desiccator.
Ali.
Yeah.
The question 3.47 grams sodium carbonate. Did you jump it?
We did it now.
It's the same thing as what we just added.
No, 3.47 grams.
Yes.
3.47 grams. We all did it together. Again, 3.47 grams sodium carbonate was dissolved in 250 milliliter standard flask. Find the concentration. So grams per DMQ is the concentration in grams per dm. That's the mass concentration. So that's 3.47 over 250 multiplied by 1,000. You are going to get what you get. So now change that what you get to molar concentration. That is by dividing it by the molar mass of sodium carbonate. What's the molar mass of sodium carbonate? That's Na2CO3. That will give you 106 grams per mole. So that thing you get divided by 106 will give you the value of the answer required here. We've done it before. Now, the next thing is, in this equation, 2 moles of sodium bicarbonate is decomposed to give sodium carbonate plus, what's the CO3? Plus CO3. Okay, plus something plus CO3. So what is that something? That's what they want us to know. Okay, what could it be? Okay, it's ordinary water now. So this one is supposed to be CO2. So we all know that CO3 will be decomposed to give you water every time. So, and because of the NaHCO3, it is 1.5 of Na2CO3. So it is water. Let's see. Yeah, clearly NO.
But what they got there
Is
nitrogen.
That's what they put there.
It's very wrong. It's very wrong. It cannot be NO.
Yes,
In
it's supposed to.
the mock is N2.
It's N2. How will it be N2, my brother?
Nitrogen.
This equation confused me tired today.
They say matter can never be
That mock
It's water.
I think there's a mistake in the question. They were meant to put H2O.
My brothers and sisters, please, you guys should listen to my sermon. I want to give you one advice. It is water does not mean you should reach exam up and be doing a giddy for now. It is NO we saw. If it is NO that is inside your mouth after you choose I beg.
No, that's actually an option. No. There are different options there. That NO is like A, that's option A. I think the actual option is option B.
Oh, I know. Seriously. What is this? And okay, maybe you wanted to write H.
what is there
You
is
wanted to write H. So you wanted to write H2O.
I don't know whether to say nitrogen water. Yeah,
So
they
when
wanted
they
to
saw
write water. Yeah.
yes. So that's why they chose C here. Wanted to write
O2.
And H2O, it is H2O, see, H2O. When a substance is not available in pure form, its solution can be standardized by recrystallization.
Limiting agent.
No.
Limiting agent. I don't believe.
No, nah.
Titration.
When the substance is not available in pure form,
Titrating against a
solution
standard
can be
solution
standardized.
with a known concentration.
When a substance is not available in pure form,
In pure form.
like titrating against the substance.
Against a concentration.
Titration against a substance of low concentration.
Thank you. So C, we continue.
Titration
The
against a
standard solution is the solution of known concentration. Or which
Yes.
one are we going to? Okay. Let's see. Dilute solution. No. Solution of known concentration. We already
Yes.
have option one. So a standard solution of a substance can be prepared if the substance can be obtained in pure state.
In a pure state.
That is B. What is the oxidation state of chromium in potassium dichromate? That's +6. +1, +4, +6, and +7. So potassium, let's do it here, everyone. Let's do it together. Or shall we just continue?
Let's do it.
Okay.
Yes, let's continue. Yeah.
People will stone you, don't worry. Let's continue. So they said the potassium dichromate, this is it, or potassium dichromate, it's Cr2O7.
07.
Very good oxidizing agent. So this thing now, the oxidation state of oxygen, chromium there is what we don't know. We are going to equate everything to 0. What's the oxidation
Yes.
state of potassium? That is 1
Oh,
times
okay.
these 2 plus chromium is what we don't know times these 2, that is 2x. Let it be x plus oxidation state of oxygen is -2 times 7, that's -14 equals to 0. So I have 2x plus 2 minus 14 equals to 0. So I have 2x equals to +14 minus 2. 2x equals to 12. Divide both sides by x by 2. X equals to +6. That's 12 divided by 2 +6. So that's the oxidation state of this compound. So we call it calcium heptahexodichromate 6. Potassium, that's the name. Potassium hepta. You know, hepta is 7. So heptaoxo. Heptaoxo, 7 atoms of oxygen.
All right.
Dichromate, that means 2 atoms of chromium.
All right.
Dichromate. And the oxidation number is 6. So dichromate 6. The back name. Oxidation number is dichromate 6. Okay, we are continuing. I want to share my screen with you. Okay. Why this same question again? Why this same question again? Please, I'm not doing the question again. We've done it before. The label on a stock bottle of an acid.
This one, the answer should be 700.
So 700 grams. Samuel, if we see this question, it's like 50 times. You know everybody has the same.
I swear.
I just reducing it there. A solution of which the concentration is accurately known is
standard.
Okay, standard solution. You see that it's not standard solution they will choose. You see, they will choose titrant.
Titrant.
They wrote standard solution here, so it is D. Weight of solute in grams per volume, that is grams per dm cube of solution in cm cube is multiplied by in cm cube multiplied by 100. That's percentage. Percentage weight over volume. That's percentage weight per volume.
Weight of solute.
This is the question. Weight of solute in grams per volume of concentration. That is grams per volume. Grams per cm cube multiplied by 100. So it is percentage weight per volume.
Okay.
Percentage weight per volume or by volume. Moles of solids per volume in 1 cubic decimeter. That is moles per dm3. That is molarity. Everybody knows it. Molarity. Moles per dm. Mole per volume in dm3. Cubic decimeter is moles per dm3. That is molarity. I don't want to solve again. See, 10 never knock. Okay, if that's the case, we'll be putting an end to this class today.
Nekeno.
Thank you so much.
Thank
Please.
you.
Thank
Thank you.
So thank you, everyone.
Sorry,
So
are
what
you
year is it?
thank you, because
Hello,
Saladin, sorry.
Kelly. What year is
On
it?
which
No.
WhatsApp group are you on?
Eh?
What do you say?
I said, on which WhatsApp group are you on,
I
please?
said what year?
I have
The question will not stop now. What year is that?
Now it's 2017. 2007.
I have
That's why I'm
question.
asking. Could you please send it to me on WhatsApp?
It is inside the
I
group.
have
It is in the group. Or
Okay,
maybe I'll send
Which
it
of
to
the
you.
Please
One of
send
us
That's
should
why I'm
just.
asking which of the group. That's why I'm asking which of the group are you on, so I know if it's there, so I can find it.
There's a group we used to make this announcement. It is now
Physics.
tutorial. Okay, wait. If you're not in the group, Odigi is not here presently. Kingsmith, I'll make you an admin now.
I can.
Kingsmith. Oh, man. Kingsmith. I'll make you an admin now. Kindly add him to the group, please.
I have a question.
Please,
go
we'll add you
on.
to the group, please.
All right.
Before we put an end to this class.
Are you sure that
What's
now?
that?
The class is ending now, right?
Sent.
I'm not hearing you, Miss Aminat.
I said you are putting an end to this class, right?
Yes.
You don't want him to.
Ah, God. God. God.
Join,
Oh,
What's
yeah,
that,
thank
Aminat?
you.
and I need to.
Like, what do you mean? What do you mean? Let's hear you, Jerry. How do you
No,
mean
I
as a
don't
kid?
like, I'm not saying